We're going to make a few standard assumptions throughout this course. The first of these assumptions is what we call rationality. Rationality means that the preferences that the players have over the outcomes of the game are transitive. So preferences are transitive. Remember, this means that transitivity says if you think the outcome A is better than the outcome B, and you think that the outcome B is better than the outcome C, that means that you have to think that A is better than C. Well, remember we're using payoffs to represent these preferences. So payoffs represent preferences. So what rationality says is, so rationality equals maximizing your payoff. So whenever a player plays a game, their objective is to obtain the highest payoff they can get. That's all rationality says. Now, when we have monetary payoffs, we're going to make some additional assumptions. So when payoffs are monetary, we're going to make a few additional assumptions. In particular, we're going to assume that people care only about their own component of the outcome. So players care only about their own payoff. So this is an additional assumption. This is not an implication of rationality. This is something that we're assuming beyond rationality. So this is an additional assumption. Not implied by rationality. This additional assumption does say that every player cares only about himself. But this is not, I don't want you to think that this is what we mean by rationality. No, this is not implied by rationality. So that's important for you to remember, that this is an additional assumption. If we don't make this additional assumption, we can indeed include things like altruism or envy in the player's preferences. So for example, if we had three outcomes, A, B, and C, those were the three possible outcomes. And let's say A involves, and there's three players 1, 2, and 3. There's players 1, 2, and 3. A involves player 1 getting $1, player 2 getting $1, player 3 getting $1. B involves player 1 getting, let's say, $2, player 2 getting nothing, player 3 getting $1. And perhaps outcome C involves player 1 getting all $3, player 2 getting nothing, and player 3 getting nothing. Now, under this additional assumption that we've made, we would typically, if player 1 only cares about his own monetary outcome, then we would normally have a payoff function that would say player 1 finds outcome C to be better than outcome B, and outcome B better than outcome A, because $3 is better than $2, and $2 is better than $1. On the other hand, so that's what this assumption means. Without the assumption, we could have a preference that looks like this. So this would be a preference where player 1 cares a lot about equality. Nonetheless, unless I say otherwise, we're going to assume this assumption. We're going to make this assumption, and so we're going to rule out these types of preferences where players have envy or altruism or care about equality, and we're just going to assume that people care only about their own monetary payoffs, unless I say otherwise. So the standard assumption is going to be that people are rational and that people have a preference only to maximize their own monetary payoff. Perhaps we'll look at a few cases where we won't make this assumption. But by and large, you should assume that we're going to make that assumption. The next big assumption is the notion of common knowledge. So we're going to assume that two things are common knowledge: rationality and the game that's being played. So what do I mean by common knowledge? Well, consider a fact F. If I say F is common knowledge between players I and J, it means the following. It means that I knows F. So I represent that by this. An arrow from I to himself labeled by F. It means that J knows F. Moreover, it means that I knows not only that he knows F, but he knows that J knows F. So I knows that J knows F. And I knows that J knows that I knows F. And you can represent that by I knows that J knows that I knows F. And then I knows that J knows that I knows that J knows F. So I knows that J knows that I knows that J knows F. And you keep going. So I knows that J knows the thing that's two steps up, and so forth. So what are the things we're going to assume common knowledge of? We're going to assume common knowledge of the game that's being played. So if we're looking at an extensive form, we're going to assume common knowledge of what the extensive form is and what the payoffs are. If we're looking at a normal form, we're going to assume common knowledge of what the strategies are and what the payoffs are as a function of those strategies. And we're, very importantly, going to assume common knowledge of rationality. So what does common knowledge of rationality mean? It means that every player is rational. Every player knows that every other player is rational. Every player knows that every other player knows that all the other players are rational, and so forth. One thing I want to make very clear here is the fact that the game is common knowledge doesn't mean that everybody knows the same stuff. It could very well happen that one player knows which of the two nodes we're at during a game's play, while another player doesn't know which of those two because they're both in the same information set for that player. So we could have asymmetry of information. They both know what the extensive form is. So if we had a game form that looked like this, so player 1 moves here, player 2 moves here, then they both know that they're playing this game. Now player 1 has actions A and B. A leads to this node, B leads to this node. During the play of the game, player 1 would know whether we've reached this node here or we've reached this node, whereas player 2 cannot distinguish between those two. So common knowledge of the game doesn't necessarily mean that they both know the same things. It just means that they both know that this is the game that's being played. So in this particular example, player 1 knows that player 2 can't distinguish between the two. And player 2 knows that player 1 can distinguish between the two. So you can still have asymmetric information.